All right, here we go. Oh man, my video is so slow. Okay, that don't matter. So we are in the third week of February, February 15th right now. Factoring with common factor, grouping, factoring, differences squared. Lots of factoring, all factoring this week. Okay, so we're going to start out with factoring with a common factor. So we already talked about the fact that for this one, we want to, oh, marker. We want to take out the GCF, right? So it's not always the case, but a lot of times the GCF is the A value, the first number. Not always. In fact, on the quiz today, I made sure it's not. So, okay, so it's 6. And then we write the 6 out front. Then we have x squared minus 5x plus 4. And then, like we looked at this week, got to factor further. So draw the boxes, put that x squared there, 4 there, x and x, and -4 and -1 would multiply to +4, but we would end up with -5x. So that is how it factors. So the answer is going to be 6x minus 4 times x minus 1. Oh, 1 second. All right. So let's put this in and make sure we got it. We got the 6 in front. Don't forget your GCF. X minus 1. All right. So now this one, I want everyone to pay attention. Not that you weren't paying attention before, but you see that we have a number in front right here, 2x squared. But we cannot take out a GCF. There's no GCF of 2, 13, and 20, right? So what do? We do this thing called, well, in Khan Academy, they factor by grouping. But I don't factor by grouping. I mean, I can, but I prefer to slide and divide. All right, and so that's the way I'm going to teach it in this video and in class. And if you click hints on Khan Academy, you can learn factoring by grouping as well, or you can just really pay attention in class. And right now, you can hold on now. Hold on now, I gotta go get a quiz. Slide and divide. So the first thing is, and we're going to use this for the rest of quadratics, labeling the coefficients. The x squared coefficient is always a. Can you remember that? A. All right. Then b. Can you guess what this one is going to be? It's going to be c. All right. So no tricks there. A, B, C. So a, just to make it clear, is 2, not 2x squared. B is -13, and C is 20. So we use slide and divide or grouping when A is not equal to 1. And we see that A is not equal to 1. What we're going to do is we're going to slide A over to the C. Okay? So now it becomes x squared minus 13x plus 20 times 2. That's the slide. Okay? Then we factor. Okay, oh, well, let me rewrite. So x squared minus 13x plus 40, and that will factor. If the thing factors, then that will factor. So let's see if I can do it. We know 1 has to be negative, so I'm thinking 40, I'm thinking 8 and 5. Oh, they both have to be negative. Okay, so it's 8 and 5 because those add to 13 and they multiply to 40. So that means that we have this now. Remember, it's not slide factor, it's slide and divide. So slide, factor, divide. All right. So now we're divide by the a. So a was 2, if you remember, over here. So we want to divide by 2. And so x minus 4 is what the first factor becomes. And you see how 5 is not actually divisible by 2? You can bump the 2 up to the front. Make it 2x minus 5. All right, let's see if it takes that. Let's see if it takes my slide and divide. X minus 4 and 2x minus 5. See? You see, you can just slide and divide. And that way, it's only one thing different than what we already learned. So I'm going to do this one more time a little bit faster. So I'm going to do the slide. So I'm going to write x squared minus 20x minus 21, right? 7 times 3. See, did the slide. Now I'm going to factor. Draw my boxes. Add the negative 20x, x and x. Oh, I know. It's going to be negative 21 and a positive. Okay, so x plus 1, x minus 21. And now I divide, and the 3 is our a value, so we divide by 3. And so that makes it 7, and then the 3 bumps in that one. So you see, that was pretty fast, right? So that's why I like slide and divide. I think it's the most efficient method. It always works. I could prove it to you, which would be a little bit more complicated. So let's just learn to use it right now. All right, now after you do slide and divide, as long as you can identify what you have, factoring becomes really easy. That really is the most difficult one. Difference of squares is super duper easy as long as you know what they are. Okay, so difference of squares means we have x squared minus some number squared. It could even be another variable squared, but it always equals x minus a, x plus a. It's the same thing, once with a plus, once with a minus. How do you know when you have it? When you have a binomial. So first of all, it's a binomial. And it's got the difference, right? Which is the subtraction sign. And then if we can take the square root of the first and second term, it's a difference of squares. And so we can take the square root of x squared and of 144, that is x times x. And what's the square root of 144? 12 times 12. So that means if that side is x plus 12, this side would be x minus 12. It's always the same thing, once with a plus, once with a minus. So this x minus. All right, so you see here, and now, do we have the difference? Yes, we have the subtraction sign. Do we have a binomial? Yes, we have 2 terms. So let's take the square root of both terms. What's the square root of 1? 1. What's the square root of x squared? X. So this is going to be 1 minus x, 1 plus x. See, whatever these are, and the 1 comes first, so I just put the 1 first in the factored form. Although generally, I know we put x first. 1. It works. All right, so that's difference of squares. You want to do one more? You got it. I mean, why don't you practice it and then put it in the organizer if you want to do one more? Ooh, difference of squares with common fact. This is when people do get confused. They say, oh, wait, what do I do now? Don't forget factoring rule number 1. We always take out the GCF, don't we? Isn't that what I said? I said that for a reason. What is 320 divided by 5? It's 64. So that's the thing about these difference of squares. They jump right out at you. So you should see that we can take this. We have a binomial. We have a different sign. So let's take the square root of the first and second term. Square root of x squared is x. The square root of 64 is 8. So this is going to be x plus 8, x minus 8. x plus 8, x minus 8. We could draw the boxes, you could figure it out. Because you would figure out that it would have to add to 0x in the middle. And so it'd work out. But you don't have to draw the boxes because once you recognize that it's the difference of squares, I think the easier thing to do is just to factor it by taking those square roots. X plus 8, x minus 8. All right, just in case you don't believe me. Now, let's talk about, exponential functions. Is this exponential, linear, or neither? Do you remember the common difference, common ratio? All right, so let's check it out. We got y2 divided by y1 over x2 minus x1. Let's see what that is. And then we'll also do y3 minus divided by y2 and x3 minus x2, right? And we'll see if we have a common ratio. So that would be 4 divided by -5 over 14 minus 7, and then 13 divided by 4 over 21 minus 7. So I have 7 on the bottom, but is 4/5 equal to 13/4? I don't think so. I don't think they can't be, because one's got an improper fraction. 13 is bigger than 4, but yeah, so it's not exponential. How about linear? Let's make do some changes. Now I did accidentally put my x's on top and my y's on the bottom. But even so, it's not exponential. Now that I look and see the y's are on the bottom, we are increasing by 7 each time. So that is a constant difference, and it is linear. I got to slow down a little bit, trying to make an ed puzzle video too fast. Okay. Let us also remember that we have our exponential formula, and this looks like our original value, and then it's multiplied by a factor of 1.02, so that goes inside, and after 5 years, that'd be to the 5th. All right, it's not too bad. Oh, don't pick that one. It's got to be this one. Okay. The expression models the per capita gross domestic product of the U.S. in thousands of dollars. What does 1.022 represent? That is the growth factor. And we know that if we take away the 1 and we just have the 0.022, that implies 2.2% growth. And so we could either say, oh, okay, it's multiplied by approximately that per year. No, that's not true. That's not true. No, that's the growth factor. Okay. When the Dragons have lost their most recent game, 200 fans buy tickets. For each consecutive win, the Dragons have the number of tickets increases by a factor of 1.1. Okay, so we have 200 is our initial value, 1.1 is our factor, and our independent variable is W. Any questions? Okay, so let's see. When we look at this, that looks like it, by inspection, it kind of looks like linear growth. But that's about a 5 increase, and then a 6 increase, and then, oh man, and then increases by 5, then 6, and then that's 4, that's 7, and then there's 9. Well, it's not, it keeps increasing more and more. So even though it doesn't increase that much more each time, like it does increase more and more each time, 5, 6, 7, and 9. I think I just got them. All right. So post in the organizer once for each assignment. See you in class.